Okay, this is my latest plane, which I call VersaCan, and that's short for Versacopter-Canard hybrid, VersaCan. So it's a combination of a flight test Versacopter, or at least parts of a Versacopter. I'm using the booms and the motor mounts, and an Experimental Airlines Ansley Peace Drone, which is basically completely made of foam board and packing tape. So there are no flight control surfaces on the airplane. All of the pitch, roll, and yaw inputs all come from the motors. And the motors on this build are able to rotate forward and backwards using a single servo. Okay, so let's talk about the airplane part of it first. This is a foam board build, typical Experimental Airlines construction. The wings, both the front and the back, are 4 inches wide, 4-inch chord. No spars except for the foam board. And the canard is 15 inches long. And the rear wing is 30 inches long. Fuselage is 30 inches, 2 inches wide and 3 inches high. And then from the leading edge of the front wing to the leading edge of the rear wing, which is something you have to know to calculate the center of gravity, 21.5 inches. And that is actually a mistake. I intended that to be 19.5 inches so that the center of gravity of the canard and the center of the gravity of the Versacopter would be in the same place. As it turns out, the canard is actually nose heavy, while the Versacopter has the center of gravity obviously between the motors. So it still seems to hover okay. I hope it flies okay. But I was too far along in the build to change it. So the canopy is just a battery box, and it's just held on with tape, with that red duct tape. And I can fit, smallest battery I've tried is 4S 1300, which is a quadcopter racing battery. This is a 4S 1800 that I use on my flight test FT270 chase quad, and it will also fit 3S 3300, which is fairly long battery. The distance between the booms is 7 inches, and with 6.4 props, that gives a spacing of 1 inch between the props. The motors on the quad can rotate forward and backwards. I intended to make it about 45 degrees front and back, but it didn't quite turn out that way. I'm not using the carbon plates from the Versacopter. The booms are mounted directly into the sides of the fuselage, and there's no bearing. The boom is resting on a 3/32 plywood plate on both sides that's been sanded so that it's kind of a loose fit, basically frictionless, but it actually rattles just a little bit. And here's the setup with the servo. I'm using, I think it's 13-gram digital Turnigy servo, and it's got one of those long servo arms that's about 1.5 inches long on it. And then just using conventional push rods, 440 type hardware. I'm using the boom clamps from the Versacopter just to prevent the tube from moving laterally so that the props don't hit the fuselage. And they're not screwed in there tightly. That's kind of a loose fit also. So the boom can move a little bit, about 1/16 of an inch. The front control rod is attached to a different place higher up on the horn than the rear control rod. So the front motor actually moves more than the rear one does. The servo also moves the boom more when it's pushing than when it's pulling. So as a result, this is the full deflection of the motors going forward. And you can see that the front motor is approximately at 45-degree angle. The rear motor is a little bit less. And then full deflection going backwards, both motors are at a much shallower angle, maybe 30 degrees or something like that. But it's still enough movement. I don't figure on flying backwards. So if I need rearward movement, it's mainly for braking or something like that. The flight controller is a Matek F405, which is an F4 type controller. And because I want to swap in different ESCs and motors, I use connectors on everything, JST connectors for the power leads and servo connectors for the signal lead from the ESCs. Here are the two boards installed in the fuselage. The lower board is a Matek FCHUB-6S, which is the power distribution board. And you can see the ESC leads, or the connectors at least for the ESCs, and for the signal leads are connected to that board. Then there's a cable, that ribbon cable that connects the bottom board to the F405 flight controller board on top. And that's the only connection between those two boards. Then on the top board, the only connection is one servo extension lead that I'm using for the S-Bus receiver. And for this build, I used a FreeSky 8XR, which has an S-Bus connection with a servo connector. And then you can also use the other channels like you would on a normal receiver. So I can put the servo that moves the motors on a separate channel, and then I can assign that channel to follow the elevator or to be on a pod or a slider or something else. So this is what it looks like all assembled. A little messy because of the extra wiring and the connectors, but fully functional. The motors are really cheap. King Kong 2204 2300 kV. I think I paid $7 or $8 a piece for them. They work okay, not high performance really. I'm using 6.4 props, which work with 3S or 4S. I used the same motors on my Versacopter, which flew okay. The speed controls are DYS 20 amp BLHeli Dshot. So not real high amperage, but fairly up to date in terms of technology. So that's pretty much the description of the whole thing. I have another video that you can watch on the hover test. It seems to have adequate control both in forward, back, left, right, and in yaw. So, and it has enough power to pop up off the ground without any problems. The only thing that I don't know is whether it's better to have the motor rotation connected to the elevator channel, which I used for the hover test, or if it's better to have it on a separate channel connected to a pot. On the elevator channel, it tends to nose down a little bit when I give it forward, and which is, I really want it to stay level when I do that, so I'm thinking that the control with a pot would be better. But I'm going to try it both ways as soon as the weather warms up a little bit. It's about, I think it's 12 degrees here in northern Illinois today, so not really suitable for the maiden flight. But so far it looks good. It looks like the maiden flight will be successful.